We're recording to the cloud. This can end up on YouTube.
Okay. Well, welcome to the May 18th, 2021 session of TangerineSDR and HamSci technical session. My name is Dave, KV0S, and this week I've done a little bit on radio. I did some work on trying different ways to run a whisper station, just to learn about the variety of different ways. I've been running one way for a while and been fairly successful, but I thought I'd try some other things. I also have been spending a little time trying to become more versed on GNU radio. So I've been spending some time looking at the modules and what each one does. And that is no small task. It takes a while to get through them. Anyway, that's it for me this week. Next on the list is Nathaniel, W2NAF. Go ahead, Nathaniel.
Thank you very much, Dave. We finished up classes last week at the University of Scranton. So I'm trying to transition from that into summer mode. So I'm doing all sorts of paperwork to keep students working, and I'm debugging code. I'm doing this ray tracing and trying to get the terminator in the right position. So I'm working with Carl Lutschel-Schwab on that. And I am gearing up to give Majid the magnetometer board that we have, and then have him start working with Jules and with Dave Witten to try and build out a magnetometer that we can install over here. So that's about it. W2NF, back to net.
Well, fine business. And next on the list is Bill, N8ET. Go ahead, Bill.
Yeah, I spent the week, I finally got brave and dove into the little circuit board for the grape and soldered a few bypass capacitors on the back of the board. And the more I do that, the more I'm leaning towards redesigning the board that use through-hole components, because when I got done with the capacitors, it looks like, well, it doesn't look like a very good solder job on the back of the board. They're little surface mount capacitors kind of standing all over the place. I think most of them are where they're supposed to be, but it's kind of hard to tell until you actually get it turned on. The other thing I want to bring up, and particularly for Nathaniel, is this weekend is coming up is the Dayton Hamvention, and it's the weekend for 4 days in May, the big QRP conference, and I'm quite involved with that. We have 678 people signed up for that this year, which is a lot. And one of our presenters is from India, and he's got COVID right now running around. So there's some question as to whether he's going to make it or not. So we'll have an hour session that we could use another speaker for maybe. So if you're interested, why there's a slot that you could do some recruiting with 678 fairly enthusiastic people that you probably get some good response or good people to be in a project. So that's something that I can get together with you and talk later on about how you might want to do that. So that's about it from here. Back to you, Dave.
Fine business, Bill, and good luck on the continued work on the board.
I might just jump in really quick and say thank you so much for the kind offer, but I'm going to have to decline right now. It's my mom's 70th birthday on Saturday, so I'm planning a family day for that. And then I'm just swamped trying to get ready for some other presentations and other work. So I'm helping Tim Duffy out on Thursday being a moderator. I'm also helping out being a moderator for Tamitha's award session on Friday. So I'm just booked. So if anyone else would like to jump in, feel free to volunteer.
Yeah, let me know towards the end, and I'll talk to whoever is interested in that. So I'll be here.
Well, next on the list, we have Jim, K4BSE. Go ahead, Jim.
Good evening. Sorry I was a little bit late. I had a net that ran a little bit long this evening. Well, I have finally gotten my Grape 1 setup working, and I'm getting data. Unfortunately, the first couple of days of data is bad. I was looking at it today and realizing that it was really noisy compared to what I've gotten from other people. And I'm embarrassed to say I discovered that I was listening on 10 megahertz WWV, and I had the jumper set for 5 megahertz WWV. And that does not work exceedingly well. I was getting some measurements, but boy, were they noisy. I would still love to find out if my Grape 1 is working exactly right. I'm getting a conversion gain through it estimated at 125 volts per volt, and I don't know what other people are getting on theirs, if that's close or not. So that's about it from here. Back to Ned.
Fine business. And next on the list is Bill, AB4EJ. Go ahead, Bill.
Thanks, Dave. Good evening to the net. What I accomplished this week was getting a Grape 1 working using digital RF, saving data, and finally I've got it to where I can plot an entire day's worth of data on a single plot, and both in spectrum and in power. So once we get into the discussion section, I will show that, and I'm looking to get some feedback on a couple of things regarding that. And let's see, also working out some issues of how we set up the permissions for when a user uploads collected data on the Tangerine local host up to the central system. It's very tricky. Version 1 of this thing probably isn't going to be all that secure because, you know, we want to get the thing working. And there's a lot of things that you can do to make a system like this secure, but there's a lot of things that security prevents you from being able to do. So we're probably going to have a second version of that at some point that that is more secure. But anyway, I can get after the heartbeat occurs, I can get the local host to upload the selected package of data, and it goes in the right place. One of my students is working on a watchdog function that will notice the data when it gets there, and then automatically strip out, or in other words, extract data in the metadata so that everything can be put into the databases and cross-reference it, and then copy the data to a back-end system in the proper directory structure. So it's a bit of a complex process, but it's coming along. Okay, back to Ned.
Fine business, Bill. Sounds like good progress. Next on the list is Dan in for XWE. Go ahead, Dan.
Thank you, Dave, and good evening all. This last week I worked mostly with WSJTX, just like you, Dave, and the Pi HPSDR program and Raspberry Pi, trying to understand a little bit better how it works. I have it up and running. It works pretty well. I'm still a little bit antenna challenged. My loop antenna indoors leaves a little bit to be desired, but I'm making a lot of progress and learning a lot about how all that stuff fits together. Anyway, back to you, Dave.
Well, fine business. And next on the list is Dave, KD0 EAG. Go ahead, Dave.
Not much to say. I worked a bit on securing the connection for uploading magnetometer data and automating it, and got that working to not to anything that Bill's working on. We know nothing about that, but to a Linode host. But as far as anything else, I didn't get anything done. Too many other concerns.
I must Well, thanks, Dave. And I must admit, I have used Dave's revision and used rsync and with a public private key thing similar to what they do on GitHub, and it seems to work fine for my uploading. I've used it several times since I first set it up. So it's working, Dave. Okay, next on the list is Elizabeth. Go ahead, Elizabeth.
Hi, everyone. Nice to be here again. It's been a long time. Just finished finals. Thank goodness. Just we've been working on our VLF prototype and playing around with an SDR that we have. We have SDR play. So we've been getting some data from around Houston with the SDR. And that's where we are right now. And just studying to pass my tech exam. So that's what I'm doing now.
Well,
Nice to be back.
welcome back, and good luck on the studying for the test, and congratulations at least getting the semester done.
Thank you. Yeah.
So next on the list is Hyoman Kim. Go ahead, Hyoman.
Hi, everyone. Yeah, I forgot to put my call sign there. Yeah, not so much has been done, although there is a handful of email exchange between Jules and Dave and myself about consolidating magnetometer design and documentation. So I'm working on it, although I have to apologize for Dave and Jules for not being able to be so responsive these days. I've been so busy with grading and stuff. Finally, all the semester's done, so hopefully I can spend some more time working on this. Otherwise, yeah, I'm still in the loop of this magnetometer project and trying to catch up, but that's it. Back to Nat. Thank you.
Fine business. One other comment about magnetometers. Dave Witten and I were able to get into the Columbia Magnetometer that Jen has set up here, and we were interested in that the reported data was a bit different than what we're collecting. So it looks like it's a compiled value as opposed to individual vectors. Is that right, Dave? I don't know if he's there.
I don't know. I don't know for sure. It's just they're only looking at, I believe, if I recall, 2 component vectors maybe in the total. Anyway, it didn't map simply, but it wasn't wildly different either.
No.
Just what they were concerned about.
So that's a small success that we were able to access that. So
Is there any data portal where we can just see data?
yeah, you have to log in, but the login's simple. We got it from Jen. So I don't know if she wants all of us logging in, but we can get some data and pass it on.
So the data is still kind of upon request, not like just completely publicly available?
No, it's not completely public. It's like a password, a user ID password, and then you can look at the site.
And I think they're a business, basically.
Yeah, they are a business.
They're not,
okay.
necessarily about now. The presentation through Adafruit.io of what's his name, the person up in Minnesota has done.
Noel Pettit.
Yeah, no, him. I like that quite well, at least as far as it goes. and he has two magnetometers, a flux gate and a not one exactly like ours. Well, it's very similar to ours. It's just a commercial version that's packaged differently.
So I just wanted to comment on that, and it worked, and so we were able to see data and look at it. So we're at least collaborating in some way with another DESI project. Okay, next on the
Dave,
list.
One quick question.
Sure.
Noel does have one of our magnetometers. So I don't know if he is using that and the commercial one, or if he has a third one.
No, he's using ours. The
is he?
last I heard from him was that he was using the one you sent, the board you sent, with an RM3100 plugged in.
Oh, okay. It was somewhere. It was just labeled as a whip motion.
Yeah, he had tried that originally, but as soon as he got the boards, he did use what we're currently using.
Yeah. Oh, that's good, because he gets temperature and stuff that way.
Yep.
So let me continue down the list. We have James, KG4DSG. Go ahead, James.
Evening all. I'll keep it short and sweet. Not much to report here. Just listening in, and with that, back to the net.
Fine business. And next on the list, we have JWB8SBI. Go ahead, Jay.
Yeah, good evening, everybody. Health-wise, still recovering from my surgery of a couple weeks ago. Playing a little FTA, and finally got around to ordering some of the surface mount tools that I'll need to work on this thing, including a training kit to learn on a practice board of how to solder surface mount components. So all of that stuff is en route, and then the plan is, once I get my test bench put back together here and learn how to do surface mount soldering on an expendable board, then I can actually start to work on the real thing with some confidence. There is one thing I would request of the group, please. 2-3 weeks ago, you very kindly sent me some information about where I can get an appropriate solder tool set. And that information has gone to the great big bucket in the sky. Could I please ask if anyone has information about where and what kind of tools, solder tools, that are appropriate to do surface mount, and where I can get them? If you would please be so kind as to email me that address. Email that wb8sbi@arrl.net. It would be appreciated. On an administrative item, Nathaniel, could I please request that the meeting announcements for both this meeting and the Thursday meeting be sent 24 hours in advance, if possible.
It's going to be hard for, we do the best we can with that. The best thing to do is it's on the HamSci website. If you go to hamsci.org/get-involved.
Okay.
If you go to hamsci.org/get-involved, there's a Google Calendar. And if you want, you can even take that Google Calendar and you can link to it and import it into any of your other calendars.
Oh, okay.
And also we decided that we're going to hold off on the Thursday afternoon telecons during the summer. So we're going to take a break from that. So we're just having the Monday night telecons and the Thursday morning telecons. But I do keep that HamSci calendar up to date. So basically what you see on the HamSci calendar on hamsci.org/get-involved, that should be what's actually happening.
Great.
And then also, if you look in the chat, there's now a link to this hamsci.org/grape1. And you can actually get to this link by clicking on the personal space weather station page. That's the documentation for building the Grape 1, and the links to the recommended soldering station and equipment are underneath building the board there.
Great.
So it's all on the website. You're welcome.
Thank you. And on a related note, the TAPR Digital Communication Conference, there was an email came out today. They took a survey about do they want to have it in person or hybrid. It's been decided that this year's TAPR DCC conference will be 100% online. There will be no in-person meeting, and they're going to try and hopefully next year to have a real in-person or hybrid event. So other than that, that's about all the ham radio stuff that's been going on here. So 73, everybody, stay safe, and hopefully we'll catch you on the air. And oh, don't forget, start getting ready for field day.
Yes.
Back to net control, WBNS3I.
Okay. Next on the list, we have Joe, W7LUX. Go ahead, Joe.
Thank you, Dave. Appreciate that. A couple of comments. I've been monitoring 10 megahertz WWV, and I'm seeing a lot less frequency excursions here the last, several days than I was several weeks ago. And back on the 25th of April, the chart actually went off scale. It was such a strong disturbance. I haven't seen anything even remotely like that since. And the last couple of days have been very small excursions and at different times, which is kind of interesting. I ordered a HAKO, H-A-K-K-O, FX888D. That's a HAKKO FX888D. This is what was at John's recommendation. And it comes with a pretty good sized tip. So I ordered a couple of the smallest tips. I'll get that information to oh boy, WB8. Oh boy. I'll need a fill on that. I'm not sure I can read my
Whiskey Bravo 8 Sierra Bravo India at ARRL.net.
Okay, SBI. That's the part I couldn't read. Of course, my pen won't right now, but I'll figure it out. Okay.
Sierra Bravo India.
Yeah. Another thing I found very handy is I had been using 0.025 diameter solder, and that's just too doggone big. I got some 0.015, and oh, does that make life so much easier to wet the pads and then put the component on it and tap the pad or put the iron back on the pad until the component welds or solders actually, and then go and pick up the other end and then clean up the first one. But the FX888D is a pretty nice looking gadget, but it comes with too big a tip. And as I say, I ordered two of the very, very fine conical tips, and that made a huge difference. One thing I'm working on is I'm a little bit concerned about, I have 5 meg and 10 meg standards running here, several of each. And I'm afraid that when WWV gets really weak, that I'm going to be sitting here measuring my standards, which are, I don't know, 1 or 2 parts in 10 to the 10th maximum. So I'm trying to figure out some way to determine whether or not that's actually happening. And one solution is to build up another grape station and station it over at the girlfriend's house, which is about 1,900 feet away. And she cannot hear my 5 and 10 meg standards. So I think that would, that may be an answer to how to determine whether or not I'm picking up radiation from the leakage from the 5 and 10 megahertz standards. And the other thing is I can go outside with a WWV receiver, one of those Radio Shack time cubes from, I don't know, 30, 40 years ago. And I can sure hear a lot of racket anywhere near the house. So there's 10 megahertz leaking out, maybe from the grape and maybe from some of the other stuff. Anyway, lots and lots and lots of stuff going on. But that's more than enough from here. Back to you, Dave.
Well, fine business. So next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. There was some pretty good discussion last week about the VLF module. So we've change our plans in terms of clocking. Instead of feeding a master clock, we'll be feeding in a bit clock, and the master clock will be generated internally from the PLL. There's the data sheet mentions that for higher performance applications, that this is the proper clock configuration. In fact, after David was telling me, I looked at the data sheet a little closer. If you feed in a clock into the GPIO pin configured as master clock, and you disable the internal PLL, the maximum sampling rate that the ADD converter will support is 96 kilohertz. So there's that's a real limitation there. So what we'll be doing is we'll be feeding or be taking the clock from the clock module, feeding that into the bit clock and enabling the PLL. And this way we could get the higher performance sample rates. And since the master clock is generated from the bit clock through the PLL, it'll still be pretty low jitter. Other than that, what I'm also going to be doing is I'm going to be building an adapter board to connect the ADD converter directly to a Raspberry Pi, and I'm going to try to take some measurements using the ALSA drivers. So I'm gonna make a I'm also going to be working on a board like that, and that'll be easy. We don't have to send it away or buy anything. We could just, I'll just make a board, solder it, and it'll be good to go. Other than that, my graduation ceremony is next Sunday, and I'm very excited about that. Back to the net.
Well, fine business, Jonathan, and good report. Next on the list, we have Jules, K2KGJ. Go ahead, Jules.
Thanks, Dave. The majority of time this week was spent on a major backyard and garden construction project and a very complicated tax issue, which was resolved a little before closing time of the local post office. Had good discussions this week with Dave regarding a 3D printed bracket for the adapter board, which should make the assembly actually substantially simpler. I've got a bill of materials of the PVC pipe material, and I'll be getting that out this week for review with Hillman and Dave. And Nathaniel will be ready whenever you want to put your assistant in contact with us here. But that, I think, is going to move quite smoothly now. And we just have to resolve a couple of small details before we can get out a general construction detail. With that, Dave, back to net.
Well, fine business. And next on the list is John, KJ6IBP. Go ahead, John.
KJ6IBP here. I look forward to being able to buy and install and use the equipment that you guys are designing. And no other traffic.
Oh, well, thank you very much, and glad you're here. Next on the list, we have Michael, AA8K. Go ahead, Michael.
Well, thank you, Dave. I just came out of a 2-hour training session for Skywarn for our county, so I'm still storming. Greetings to everyone listening. Back to you.
Well, fine business. And next on the list is Scotty, WA2DFI. And I got a message for you, Scotty. You need to check in and vote on our board taxes.
I know I saw that, Dave. Thanks.
Okay.
I read everything. I don't necessarily respond very promptly.
Well, I knew that I was going to see you or talk to you, and so I thought I'd pass the message along.
Yeah. Okay. Thanks. I have a message for Bill, AP4EJ. I got the tracking number. I'll email it to you on that shipment that is. I think you must live in the black hole down there or something, because we shipped stuff out to Missouri the same time as you, and he got it a week ago. So they just see your address on there and they say, put that aside. Bill doesn't need it for a couple of weeks. We'll deliver it
I can
later.
believe that. Yeah. Happens all the time.
Yeah. So anyway, a couple other comments on when Jules, when you get to the and Dave, when you get to the bracketry for the MagnetoPi, I want to make sure that the updates to the manufactured one that Tapper's going to produce are going to be fit in with your bracketry. So, I need some feedback on what we're going to do, what changes we're going to make there to make sure they are going to not interfere with anything and it's going to work with your bracket. So I'd like to get together with you guys before I make the changes. I've been kind of sitting back waiting, but there's going to come a time when I want to finalize that and get that up so we can actually put it up at the storefront and have people buy them.
Yeah, I think basically it's the hole spacing and hole sizes that are the most critical item.
Okay, well, because I was talking about turning the connector 90 degrees and putting it at the other end of the board, which
that would work. Yeah,
Scotty, you just have to. Well, we really need to interact on that. We need to make sure that what you're thinking and what we can do are just working together, because it's not that it's very hard, but the 1.5 inch pipe is not real big, and so there's only so much room. We have to be sure everything fits, but otherwise I'm currently printing things for the boards I've designed for my own use mostly, and they fit nicely, but I'm not absolutely certain how your dimensions are going to end up. But once I know, I can do something in that, something that works, I think.
Scotty, if the board or the connector at the opposite end of the board is fine, it's basically the size. Is it going to be the same physical length and width? And there are 4 hole, or there will need to be some mounting holes in the corners that would correspond to some sort of a bracket for mounting. Other than that, as long as the connector is in line, it should be fine.
Okay, because I definitely want to talk about mounting holes to make sure it's compatible. And I didn't. That's what I was hoping for, Dave, is to get together and work out all the differences, because I think if you put the connector at the other end and center it, then it's going to fit in the 1.5 inch pipe much better. And
that's exactly what these boards are. So and in fact, it might be ideal not to put the mag jack on there at all, because the best fit is always going to be without one at all. And
we're talking about options of that and the 40-pin connector of being optional.
Yes,
being
optional.
And so, because they're both through hole, those are the most expensive things to install. So let the user do it. And of course, we will have an option for the user who doesn't want to solder at all if they want to add those options. But that will be something that we can discuss. And because you can't really move the 40-pin connector anywhere and have it work for Raspberry Pi, but you can definitely move the RJ45 or leave it off. And because we're going to have a parallel header with the RJ45 to allow you to remotely mount the RJ45 wherever you want.
Good. Let's get together this week then and make that decision.
Okay, sounds good. So
I'll be available, I expect, anytime.
Same here.
Sounds good. And as far as Jonathan goes, on your Raspberry Pi adapter board, I think if we work this right, you can make your VLF module be a Raspberry Pi board, and you won't need any adapter at all. just be able to, because the connectors that you're going to use to talk to the data engine are going to be the same pins that you talk to the Raspberry Pi. So let's just use the same pins, and then you can plug it onto the Pi, or you can plug it onto a data engine, and it'll work either way. So anyway, we can talk more about that. I think you only need about 5 pins, and that I've got way more than that on the Pi connector. And now that we're doing the bit clock instead of the master clock, it's a much slower clock, so it'll be a better solution.
Well, yeah, that's the plan. The ultimate plan is to have this work in both the on a Raspberry Pi and on the data engine. I just wanted to make this quick board, this a quick adapter board for purposes of getting the drivers and everything working on the Raspberry Pi, and to be able to take some measurements with VLFRX tools.
Yeah, except that if you pick the right pins, you won't need an adapter. So why not just do it with, I mean, maybe I'm not understanding, but it seems like it would just be pick the pins on the Pi end, and then it works on either board, and you don't need any adapters at all.
Well, this is just a prototyping thing, just for me. Something I could get made at OSH Park. You know, something quick. It isn't meant to be like a, you know, part of the final product. It's just for Raspberry Pi driver development.
Okay.
And performance evaluation. That's all.
Okay. Just thought I'd bring that up. And as for forget who it was talking about solder and their new, I think it was Joe. I got 2 rules of thumb. Is the finest solder you can buy, which is 010, and you'll find if 015 is better, 010 is even better than that. If you could find it, it's very expensive, unfortunately. The guys who actually come to the Arizona swap meets carry 010 most of the time. So if you can find a roll of that, and they're usually $10 or $15 a roll compared to like $80 a roll if you buy it retail. And my rule of thumb for soldering tips is, if you can't poke yourself and draw blood, the tip's not fine enough. it's got to come to a you know, pick your teeth point. It's got to be really like painful if you stab yourself. And I'm talking about with the heat off. So anyway, what I was going on this week, we made the executive decision to remove the 3-port Ethernet chip and put on the 7-port Ethernet chip, because I can get it, and it's less than $1 more than the other one. So, and the beauty of it is it has a GMII port rather than an RGMII port, which means that instead of double data rate clocking, you use a single data rate, which is much quieter and much nicer for the FPGA. The downside is I got to come up with 8 more FPGA pins, and that's what I've been beating my head against the wall for the last week or so, among other things, trying to figure out how we're going to do that. The CAD guy standing by, he's bought into it. He's got the symbol made. He's pretty much juggled things around so that he can fit it in. And so I think it's going to be a go there. The other problem we've had is the oscillator for the clock module. Okay, we got a data sheet from Raycon. It said that the clock module, the clock oscillator could be anything from 30 to 52 megahertz. So we go into them and we try to order a 50 megahertz version. Actually, we ordered anything between 48 and 52, which is what the range that we need. And they came back and they said, well, we're not sure we can make anything at 50 megahertz. And if we did, the yield would be crummy, so the price would be really high and the lead time would be really long. And we've got so many orders for stuff, we're not even worrying about small people like you. I mean, he basically said that. He said, your annual usage is not enough for us to do a custom. So he says they're actually turning away business, which for the first time ever in the time he's been there. So I'm reading between the lines here and I'm saying, you ain't going to get a clock from these guys. You're not going to get anything that you need. So we're back over to Microchip and Vectron. And John Ackerman is analyzing which clocks are going to, and Tom McDermott too is helping us, pointing out some things that I didn't really realize are important. And you can't just look at the phase noise. There's lots of other characteristics that have to be taken into account. So they're trying to figure out what clock oscillator we can buy to substitute for that. Then we're going to have to go back and redo that area of the clock board to put that oscillator in. And hopefully it's not a way bigger oscillator, or, I mean, there's not very many pins, right? Power, ground, and out, but there's the size of the oscillator. So we'll see how that goes. So those are the two biggies. And then we're down to one part that's available by September. And of course, the FPGA, I still don't have a delivery date on. Always seems to be the one that should be the easiest one is the one that I can't get. So anyway, that's the last two parts that, and pretty much other than those two parts, well, the oscillator and the FPGA and the USB 3 part, everything else is sitting in the other room in boxes, all ordered, received, ready to fire away as soon as we get the last parts. So, and if anybody has a suggestion for a replacement for the FT601Q, let me know, because I'll design it out too if I can find a replacement. But no one makes a USB 3 to FIFO interface that is in the same kind of footprint that I can get. Cypress apparently is having difficulties delivering also, so their USB 3 interface is on the rocks. So here we go. When we get those parts, we'll be ready to build. So back to you, Dave.
Well, fine business. And next on the list is Tom in 5EG. Go ahead, Tom.
Oh, good evening, Dave and everyone in the group. I've been working with GNU Radio 3.9 and the Open HPSDR modules. I'm documenting receiver measurements for an upcoming GNU Radio presentation. And it just so happens to be the similar measurements we need to make on TangerineSDR. So kind of getting two birds with one stone that way. I found an interesting 10 megahertz spurious response on the Hermes. And I thought it was one of my 10 megahertz lab standards. So I unhooked the coax and it was still there. So I unplugged the lab standard and it was still there. And I found out it was the 10 megahertz internal clock in Hermes leaks through, and you can see it on the input. So spurious can come from everywhere you can think of and few places you can. So back to the group.
Well, fine business, Tom. And that brings us to the end of the list. I don't think I've missed anybody. And
Mike?
So, oh, did we, who?
Did we get Michael Neruda?
Yes.
Oh, okay.
He was talking about he'd been in storm chasing.
Yeah, okay.
Mode. So, and Michael's been compiling some of John Melton's code this weekend too. I'm aware of that. So,
Thanks
anyway,
for the help, Dave.
You're welcome. And so I think we're open for general discussion.
I have something that I wanted to run past the group, and I think Tom may have some useful input on this. Could I share my screen? I will show you what I'm talking about. I mentioned this earlier. This is a 24 hours worth of data collected via the grape using GNU Radio. All right, can you see that?
Oh, yes.
Yep.
All right, this, the left-hand side of the screen is 10 a.m. local time. That's 10 o'clock in the morning, central daylight time here in Northport, Alabama. And I lined these up so you can see the top is your frequency where you can see this is sundown. In other words, the sunset, and you can see a little bit of Doppler shift as the ionosphere moves up, and then here is sunrise. And so you can see a little bit of positive. It's interesting, you get a little bit of positive Doppler shift here at sunset as well, which is interesting. The lower chart is power. The way I interpret this down here is this area is when the D region is present and is doing some absorption. And you can see as the sun goes down, the strength of the 5 megahertz signal improves. And then as the sun comes back up again, it drops back down again. Now, the question I have on this is, look at the wide range of power levels in here. I haven't figured out a way how to look at the distribution of these signals. I guess maybe it could be a Gaussian. That would kind of make sense. It's interesting here that you've got quite a bit of overlap in the power levels between daytime, which is this, and nighttime, which is here. And my question, maybe Tom can, somebody can tell me, all right, is this wide range of signal strength levels because I've got something wrong in my GNU radio setup, or is this normal and to be expected? And I wonder if there's any way that I can collapse this down to, this is using digital RF's plotting tools, which I think behind the covers, it probably is using some MATLAB or Matplotlib functionality. Anyway, does anybody have any thoughts on that?
Okay, so Bill, you're feeding IQ samples into digital RF?
Yeah, right. Digital RF is recording IQ samples and saving them that way. That's the standard way it works.
Okay, so any power estimation is happening inside digital RF and not within your flow graph?
To the best of my knowledge, that is true, because remember when you and I developed that, it was mostly your input, where it takes the audio source, it runs it through a Hilbert, and then there's a signal source that is 1 kilohertz, and then there's a multiplier that takes the output of the Hilbert and the signal source and multiplies those two together and then runs it through a low-pass filter.
Right.
And that gives you your waterfall that is very close in, your narrow band waterfall. And
right.
So I'm just taking the data that's going into the waterfall and saving that. So this is a narrow band. The digital RF is very narrow band. It's 10 samples per second. So it's about 10 hertz in width. And so the numbers that you see here, these are real numbers here. So this thing is you're looking at 5 hertz on the upper chart. And the same data goes into the lower chart.
Okay, so it's hard to know exactly what digital RF is doing in terms of interpreting the power from the complex signal. I suspect that some of the variation you're seeing is real and is actually occurring. And some of it could be sampling artifacts. You know, if for example, digital RF were estimating the power at 10 samples per second, right, it might catch the signal at a zero crossing and say, hey, there's no power because it just happened to be going through a zero crossing. Or it may have an entirely different power estimation, in which case that wouldn't be the case. And so without knowing what digital RF is doing, it's hard to know what that output amplitude represents.
Okay. Well, I just thought I would run it past the group to see if anybody had any idea. We get excellent support from Ryan Volts over at MIT Haystack. I might run this chart by him and see if he has any suggestions on how to get, how to interpret this. I mean, it may be that this really is what it is. That.
Hey, Bill.
Yeah.
I mean, I suggest for something you might be able to try. If you have a way to a signal generator with an amplitude sweep on it, do you have anything like that?
No, I don't.
You might be able to do it just with a fixed amplitude, but I was thinking just input a fixed signal, disconnect your antenna, put a fixed signal in and vary the amplitude and see what you get coming out. And you'll know what you're feeding in. And so if you get something different than what you're feeding in on the output, then you know something funky is going on. I mean, just as a test, to see if it's processing it right.
Actually, that's an excellent solution or excellent idea, because I have a red pitaya, and I believe if I put the original chip in that came with it, it will operate as a signal source. I believe it will do that. So I can try that and see how it compares.
But if you have
you can also do that all in the new radio. Just make a 1 kilohertz signal source and strip out your whole receiver and just have the new radio pump in a 1 kilohertz signal source to digital RF.
And if you amplitude modulate that with like 0.1 hertz, you can get a varying amplitude coming in.
Yeah, that's a good idea. All right. Well, that's why I showed this. I knew that somebody would have some good ideas on how to.
Yeah.
Given the fact that the amplitude minimum are different between day and night, I'm going to infer that a lot of what you see there may in fact be real.
Yeah, I mean, if you look at the shape of it, to me, it looks like what I expect it to. It's just the range of values, the amount of overlap between the day and night is what seems kind of funny.
That's 40 dB of amplitude there. I mean, each one overlapping 20 dB.
That's what I mean. Is that what you would expect?
Seems excessive to me, but I don't.
Yeah, that's the reason why I'm a little bit fuzzy on this. And it could be entirely sampling error in that, it's set at 10 samples per second. You're not going to be integrating very much, I guess. But
hey, Nathaniel, do you have any of Christina's graphs handy on your computer there?
I probably have some of them. For which particular day?
Or John N80BJ's, the graph that they have put up many times of just a 24-hour period showing the Doppler shift of WWV, because it shows the amplitude on one of the graphs.
Yeah, I mean, I even have my own here that because I'm collecting them also.
Well,
just to see compare it to this.
It would be interesting to compare that to compare the. Nathaniel, if you happen to, their charts begin at UTC 0, so we would have to shove them over to correct for that. But
yeah, but there's definitely a big diurnal variation. There's a huge diurnal variation.
Right. That's to be expected.
And the one thing that you need to know about looking at John's plots, which I can bring up here in a minute, is that they're filtered. So he runs them through a low pass Butterworth filter before they actually get plotted. And if you're actually to plot the raw data that he puts out, it's much noisier than what you normally are used to looking at.
Because Bill, you're not arguing that the diurnal variation is excessive. It's that the peak to peak variation within the night or within the day seems to be very high.
Yeah. If you look at how fat this signal, how fat this plot is, I didn't expect it to be this fat, which tells me that the signal strength is varying all over the place.
Yeah.
And if you were to average all those samples, you get a non-overlapping variation between day and night, which would be
Yes, sure. I mean, this down here at -60 is about your -60 dB is your daytime, and about what -30 dB is your nighttime.
But if digital RF is not doing any filtering of the amplitudes, it may just draw a bar between the maximum and the minimum, regardless of how it's actually distributed. And just the small, at a given instant in time, it may say, within a few seconds of sample bin, the bottom is the minimum amplitude I saw and the top is the maximum amplitude I saw.
Hey, Tom,
in which case noise and other things could cause the effect.
Yeah.
But even the signal's a sine wave, right? So if you're actually sampling at a very high sample rate, then the dips in the 10 megahertz sine wave would be the bottom and the dips would be the top. So, I mean, am I not interpreting that right? Or
no, I think the power is the peak to peak amplitude being small or the peak to peak amplitude being large.
It reminds me, that looks a lot like the ones I was getting. And I kind of chalk that up to noise, which I'm trying to improve and see if that doesn't make it better. But yeah, I've looked at some that UX and some other people have done, and they are a lot cleaner than that and a lot cleaner than what I was getting.
Yeah.
I'll know in a bit whether it was noise, because I did find the problem, which got the signal up some.
But don't forget those plots that John's software does by default. They're filtered.
Okay, I was going to ask. I heard you say that, and I suspected they were.
Yeah, and I just fully appreciated that only this week when my student Veronica was plotting the data, manually. Finally, and she's like, this is all really noisy, and Bill Lyles and I looked at it and we looked into John's code, and it's a low pass Butterworth filter. So probably if you just take his raw spreadsheets, if we take his raw spreadsheets and plot it, it'll probably look similar.
Yeah.
So this is a wide band, like 500 hertz or 1,000 hertz, or
no. What you're looking at here is a 10 hertz wide.
It's 10 hertz. Okay.
Yeah.
But the time scale is a long time. There's an entire day down there.
The whole day. This indication down here in seconds, that's real. You got 86,700 or whatever it is seconds per day, and this is the actual elapsed time in seconds on the.
But you only have maybe 1,000 pixels horizontal on that bottom graph. Maybe even 500 pixels across.
Right.
And so any one pixel is going to represent, hundreds of seconds of time. And so the amplitude could be the signal, the maximum signal and the minimum signal in that several hundreds of seconds of time.
Yes.
And so if it plots just a bar saying, here's the biggest one I saw, and here's the smallest one I saw, then you could get a graph that looked like the bottom figure.
So fading would appear as just fattening up of all those samples.
Or even just noise.
Yeah.
Bill, you might try only plotting a short period of time to see how it's moving from sample point to sample point.
Yeah, that's worth doing. I will do that.
Yeah, in GNU Radio, you can extract the magnitude of a signal, which looks at the complex I and Q and basically gives you the square root of I squared plus Q squared. You don't even need to square root it if you don't want. And run that through a low pass filter and just put that onto a display and change the time constant from, a hertz down to, tenths of a hertz. And you could probably very quickly get an eyeball understanding of the noise, what that signal looks like. I think, in fact, you've got all the tools in GNU Radio to do a quick look at it.
You said that bandwidth of that measurement is 10 hertz. Where's that set?
That's done using a decimation that goes on in GNU radio.
Okay.
The GNU radio takes the audio in the sound. Basically, it's a sound card. It's a USB sound card device, and it runs it through a Hilbert filter, multiplies it times a 1 kilohertz signal source to get it in centered around 0 hertz. Then it runs through a low pass filter with a decimation of 800. So it takes the 8 kilohertz, which is your audio source, and decimates it down. And you know what's interesting about this? I just thought of something. I've got the audio source sample rate set at 8 kilohertz. But I wonder if this sound chip has a wider bandwidth than that. It's not 44 like you would think. It's weird. It's a weird number, like, because it's a very cheap chip. It's maybe like 23 kilohertz or something. And I wonder if noise is being folded in because I have the audio source in GNU radio defined as 8 kilosamples per second.
You always have to worry about aliasing on any, without looking at the flow graph, it's hard to know, but you have to worry that at low data rates, you could alias noise on top of the signal you're trying to measure.
Yeah.
But
so that
I think, there's any number of possibilities here. We don't know what a digital RF is doing when it draws the picture at the bottom. And so we'd need to experiment with it a little bit. I think you have the tools without getting any hardware. I think, in fact, you have the tools to get a sense of what's going on.
Okay, all right. Well, you've given me a lot to think about, and I'll go and take a look at this and see if.
Before you put that away, I wanted to point out to Joe W7LUX that I know, Joe, you're very concerned about the lab standards, and we should be, but as we move toward this spectrum display and recording the spectrum data rather than just a single type of plot that we have been doing, that will help to diagnose whether you're seeing just the lab standard or the solid carrier, or if we're going to see these other Doppler shifts.
Okay, understand.
Okay, thanks.
All right, thanks very much.
Scotty, I wanted to mention Microchip purchased that company. I forget the name of it, but I think that's a good choice as an alternative to Raycon, because I've also tried to get parts from Raycon and in the past, and if you're not doing a big order, they don't really want to talk to you.
Yeah, not really wanting to talk to us is pretty evident.
Yeah.
So,
yeah.
But the problem with the Vectron is it's very expensive. So.
Well, yeah, their products, they have really good temperature, performance, and they also they make a lot of mil-spec stuff. So that's the thing. It is expensive, but
because even in 100-piece prices, that oscillator is $45.
Yeah.
But then the Vectron, the Raycon one's not cheap either. So, and it doesn't really matter how much it costs if you can't get one. So my oscillators are $1, but you can't buy any.
Yeah.
How many times have we heard that? Oh yeah, if I didn't have any, they'd be cheaper too. So,
Well, is there going to be more discussion about the clock module and about its holdover? Because I was concerned about that too, since we talked about that last week.
well, I mean, we could discuss what the specs are because the clock module is already designed. However, it's not really designed because we don't have an oscillator picked. So that's going to be the determining factor. So, and the trouble is, I think, to address this to Tom, we don't really know what the requirements are, right? We're just kind of picking an oscillator based upon the best that we could get.
Yeah, the holdover is dependent on the oscillator performance. And the more expensive the oscillator, the better the holdover performance. So it's a trade-off between cost and what we need to achieve. And so we have to kind of strike a balance between those two. We saw the one data sheet John had like a 0.04 ppm, 24-hour holdover performance, which in my view is very good for a small part. It's an extremely expensive small part. The very inexpensive devices had very poor holdover performance. So what John's looking at can do holdover. It can identify GPS loss of lock and use the crystal to do the holdover, but the holdover performance is going to be pretty dependent on that oscillator, is my guess.
Which is why we want to use a good quality one, that's i.e. expensive.
Yeah, and that's that's the secret of engineering, right? It's trading off the cost and the performance.
It's just that the clock module now is going to cost more than the data engine.
That's for the platinum version.
That's right. We'll give you the tin can and the string version for $1, but if you want performance.
That's exactly right. If you look at standards with extremely good holdover performance, the HP 3800 series, they used double ovenized oscillators to achieve good holdover performance. And so that's, the performance of that standard is going to really depend on that part.
But so really a TCXO with the kind of holdover performance like 0.01 or 0.1 ppm, that's pretty amazing, isn't it?
I thought I was impressed at 0.1 absolute and a 0.04 ppm in 24 hours for a small surface mount part. I was pretty amazed by that spec. I thought that was impressive.
Yeah, because it seems like that's more like an oven controlled result rather than just a TCXO.
Yeah, it could be that the TCXO has a small microprocessor inside and it learns and it measures the temperature and it predicts and it compensates. We don't know what's inside there.
Yeah. And of course, John's measured the temperature, I mean, the output over temperature, right? So we can see how it changes, whether it's, because I know that was one of the problems with the GPSs, that it did correction, but it did a magnitude correction that became a sawtooth on the output, right? Because it did a bulk correction instead of a slow.
Yeah, when you go into holdover, of course, it's not listening to the GPS.
Yeah. But then how do you, I mean, if you're doing the scenario that you described where you're measuring the temperature and saying, well, I guess that the oscillator is going to be off by so much, we'll correct it. It depends on how you correct it, right? Do you correct it once every second and then whatever the increment is, it could be big, or do you correct it much more rapidly and have a slow adjustment, a slow track?
You don't know what the artifacts are going to be in that part until you characterize it.
So,
well, so for the 1 PPS, since the SI part won't be generating that, when we do go in holdover mode, what's going to happen with the PPS other than it'll be as best as the GPS could get?
Well, in holdover mode, the synthesizer part sees loss of timing lock from the GPS, and it freezes what it does based upon its 48 or 50, whatever megahertz crystal oscillator. That's the part we're talking about. That is what then determines the output timing.
But the PPS output of the GPS continues on as just a guess, right? A free running.
Yeah, you'll have to talk to John about what part, which pulse train comes out of what part. But that synthesizer chip has a holdover mode built into it.
Right, but the one PPS comes from the GPS.
Okay, well, the one coming from the GPS is gonna go somewhere.
So will it either go away or it'll just drift around?
Yeah, I don't know. You know, you could independently derive a one PPS from the output of the synthesizer chip. Not sure.
And I think I looked at that because it's pretty catastrophic if it goes away. But if it drifts around, then at least you still get a one PPS, even though you're not as accurate. And I think it persists with the PPS output, although it, it's in holdover mode, so it's not as accurate as when the satellite is in lock.
Yeah, I don't know how far that's going to go.
Yeah.
So that, as they say, that's a John Ackerman question.
Yeah.
Okay. Well, because with the RF modules, will they also be utilizing, or will the FPGA be utilizing the one PPS signal when the with the RF modules?
Well, the FPGA will have to use that to generate the timestamp.
Yes.
But the RF module itself doesn't use one PPS, right, Tom? It just uses
right. It just uses the 122.88 megahertz clock to clock the A to D. It's the FPGA that has to process one PPS.
Okay. All right.
So the FPGA could, in theory, synthesize one PPS off of the synthesizer output from the clock module if the GPS went into, a failure mode.
Okay.
We were talking about doing that actually, because the GPS will tell you out of the serial output in sentences when it loses lock. So when that happens, the FPGA can be aware of it. So the FPGA can decide, well, okay, my timestamp's going to be from my own 122.88 divided down one PPS generated, or if the PPS coming from the GPS is still better than what I can generate, then use that. Or if the one PPS goes away completely, I can still do a timestamp with the generated PPS.
Yeah, you could count down from the synthesizer chip. At any rate, that's all guessing on our part. We need to get John's advice there.
Okay. All right. Yeah, I was just wondering about that. I mean, there's probably, there's a lot of solutions to this problem. So we could just figure out one that works the best. Because that's going to be necessary for VLF module operation. So I just wanted to understand that.
I think it's necessary for both VLF and HF.
Oh, definitely.
So lots of testing to be going on, and we have real hardware.
If there's a lull in the conversation, I plotted the unfiltered voltage from one of my grape days, unfiltered power, if Bill wants to see it.
Oh, yeah.
Yeah, I'd like to see that.
Okay.
Make for an interesting comparison.
Yes.
There you go. So this is from January 17th of this year, starting at 0 UT and going to.
Gee, that looks like not quite as much, but so the nighttime is on the right-hand side and the daytime is the left-hand side.
Mm-hmm.
What frequency is this?
10 megahertz.
Okay. That doesn't look too much different than mine. Curiously, you have less variation in the low signal level area than you do in the high.
Right.
Which is a little bit curious because I would have expected noise to be playing into that somehow.
Right.
But mine was a little bit more noisy on the left side and similar on the right side. So maybe I'm not quite as bad off. Now that I found my problem, I'll plot that data and see if it looks any better.
So Nathaniel, do you have any explanation why you get like those 3 humps on the nighttime, on the daytime? Like this on the left side there?
So at nighttime? So
Oh,
I think
that's daytime on the left side, right?
no, I think
Because
so let's see, 0 UT. So if that's 5 hours ahead, that's like 8 p.m.
It'd be 7 p.m. your time, or it's 8
Yeah.
p.m.
So this is an amplitude graph, right?
Yeah.
There
So
could
this
be
is
traveling ionospheric disturbances in that.
that's my guess. This is like TID sort of activity that we're
But I would
working
expect
on.
at 10 megahertz, the nighttime should be higher than the daytime, shouldn't it?
Not necessarily. You get
No, I sometimes get best signal late afternoon and into the evening, but other times I'll get it during the day. It acts more like 15.
Yeah. Is that power relative? Because I mean that's you're looking at the audio signal there. Is that relative power?
Yeah, I'm sure it is.
Yeah, you don't have a gain, fixed gain reference to make it absolute.
Yeah,
it's just relative.
Yeah, I would think that that the amplitude in this case doesn't really matter all that much. Doesn't really tell you that much because it's relative to the audio signal, and that's very similar. It's a very similar situation with VLF signals. Is that unless you do a calibration, an amplitude calibration, all your signals are really relative, and the amount of amplitude variation doesn't necessarily tell you anything.
Right. But there's a good chance that these are actually traveling ionospheric disturbances.
Do you have the filtered version of this, Nathaniel?
Yeah, the original John's version. Let's see. That would be here. And that would be here. And here. I think I picked this 17th.
Yeah, and you can see the TIDs.
You can see them, yeah.
But look at how smooth it is compared to the 40 dB of noise.
Yes.
So
much gooder.
Well, also bear in mind that you've got some averaging going on here.
Yeah.
But it still looks like, Bill, about 30 dB between day and night.
Right? Yeah.
So if you were to average yours, you'd come out with something very similar to this.
Yeah. Right.
So I mean, like I think you could, well, with the graph on the right, you could run that through some negative gain to try to decrease the amplitude of the signal, and then then it'll probably look like the graph on the right, except not average. Because that was Bill's original question was there was a lot of amplitude here. What's going on? And it just seems like to me that's just the relative amplitude of the audio signal. Um, even though that there is some TID activity there, I could see it too. I was just saying that that the amplitude really didn't matter.
One thing that it does make me think of, though, is that it seems possible that I have a lot more noise, like I could adjust this system. I have a lot of noise that's being introduced by artifacts or aliasing, I think. So I'm going to try and get the audio sampling rate in the GNU radio closer to the actual audio sampling rate of the, well, here's the thing. When you use GNU radio and you set the audio sampling rate of an audio source block, you're actually setting the audio, the speed of the D to A or the A to D converter in the sound card, right?
Not always. It depends on the driver. Sometimes you actually change the sample rate of the codec chip. Some implementations, however, actually do rate changing in software inside the driver module. And so some of the drivers don't change the codec chip, but actually decimate and filter and resample the data before feeding it to the software. So it depends on the driver and the part.
Well, the question is, though, let's say that I have a sound chip that's capable of running at 24 kilosamples per second. And in GNU radio, I set the sample rate to 8 kilosamples.
A lot of the codec chips will have 8 as one of the standard hardware implementations in the codec chip. They usually will have 8, 24, 44.1, 32, 48, and a couple of others. And if that's the case, then probably when you change the sample rate, it actually goes out to the chip and changes the actual clock rate of the chip.
So then the question is, am I folding in noise? Because it seems to me that the grape has a filter in it that filters such that 8 kilosamples per second should be filtered.
Yeah, if you are running your audio chip at an actual 8 kilosample per second rate, then any noise higher in frequency than 4 kilohertz or higher in frequency than negative 4 kilohertz will alias into what you're measuring.
You know, you straighten me out on this. Straighten me out on this. Since we're only sampling once per second in the FL Digi software, should we be filtering that below 1 hertz before we do the samples? Are we getting some aliasing from that?
No, the way FL Digi works is it's not really taking just 1 sample per second. 1 second, every 1 second, it's looking at the last 24,000 samples or something. It's using a statistical technique to do some estimating. This is a discussion that Case Western Reserve already had.
Okay.
Yeah.
It seems like something would have been addressed, but all of a sudden I couldn't figure out how it worked.
Yeah.
Okay. So FL Digi is sampling a lot faster and then doing some filtering on that faster rate before it does.
Yeah, I mean, it uses I can't tell you, I don't really understand the internal guts of it, but it is using a batch of, it's using like a sliding batch of samples.
Yeah, yeah.
Yeah, that's called a moving average filter.
Something like that. Yeah, so it's doing something like that, but it's got this statistical technique that supposedly enables it to avoid avoid having too much information to be lost by the averaging. I guess you would say it that way.
Okay, you've aligned that fear. Thank you.
So without knowing how this particular sound chip works and the driver, we can't really know if 8 kilosamples per second has folded in noise or not. We can't really know for sure.
Right. You would hope that if it's done in hardware, that when they designed the chip, they would have had a 4 kilohertz low pass filter in front of that codec. You would have hoped that they would have done that. But your statement is true. Without knowing the chip, we're not sure what's going on.
Yeah, I mean, how much can you expect for $9 or whatever that particular chip is? It's very inexpensive.
There you go. That's a Scotty question.
Oh, but who knows? I mean, when you're building stuff in the millions, it may be that, you know.
Yeah, what's a couple of 100,000 transistors among friends, right?
Yeah, really.
Really, look how many your Pentium has in it.
That's right. I've got to run. We'll see everybody next week.
Okay.
Thank you, Tom.
I got to run too.
Thank you. 73. Enjoyed it. Thanks for the input.
Thank you.
Bill, I'll send you that tracking number and let me know when it shows up.
Thanks very much, Scotty.
Nona actually went and checked, and it says it's in transit in Atlanta. So I don't know how long it will take to get to you.
I mean, that's fine. I mean, I don't necessarily need to track it every minute. Just always, I'd like to know that it wasn't lost in shipping, because sometimes that does happen, but it's not that frequent.
Yeah.
Thanks very much. We'll be in touch.
Will do. 7-3. 73.
73.
So a quick question, Nathaniel, your talk is, what is your talk that you just prepared the abstract for? That's like in July?
That's July 31st.
Okay.
It's for the Society of Amateur Radio Astronomers.
Yeah, okay. And they're doing that it's virtual this year, right?
Right. I'll be doing another one for CEDAR in a couple weeks too, or in a month, but they didn't require an abstract right away. So
okay. Yeah, because the Sarah guys, I was trying to kind of recruit for Tangerine and was not having much luck because they were at Hamcation.
I remember that.
They were in the booth next door to us, and they were just kind of like in their own little astronomical world.
Yeah, I mean, actually, if you're able to be in the audience for when I give the talk, that might be useful in case there's any like really technical questions about the architecture.
Yeah, I can do that. It's at the end of July.
Mm-hmm.
Yeah.
Yeah, because I'm kind of like a high level kind of person.
Yeah.
So yeah, that would be really helpful. And Bill Lyles has warned me that this particular crowd is very technical, and they are good at asking technical questions. And very often the answer is, I don't know, or let's talk about it over lunch.
Well, good. That's a good crowd to be in front of.
Yes, it is.
Yeah.
Yeah.
And then the CEDAR talk is in.
That's
September?
in June.
Oh, it's in
CEDAR's in June. Yeah. So I'm also supposed to be doing a talk. I'm supposed to be recording a talk that's supposed to be done already for the Super Darn workshop that's next week. And I had some bugs in the code for that. And so I'm kind of behind the 8-ball in that thing right now.
Well,
so
yeah. Is the CEDAR is the German Friedrichshafen, or is that different?
No, that's different. CEDAR is a National Science Foundation conference. And that's basically the conference where we, like, that group is where we get our funding from. So it's kind of important.
So it's kind of important, yeah. Because I
Yeah.
know Dev has said that the Germans had asked him to do one for Friedrichshafen, which I think is going to be virtual this year, or
Right.
Conval maybe.
Yeah.
And I told him that it's on field day weekend, unfortunately. So
Yeah, I turned that one down too. I'm
Yeah.
starting to turn down like more of these things. Like you saw tonight, I had to
Yeah.
turn down.
So
But I'm just so swamped. It's like,
yeah,
it's crazy.
So is Josh still doing that? Is Dev still doing that?
I don't know. I'm not sure what's going on with Dev and that,
Because I
because
told them I would record one if they wanted one.
yeah, no, I haven't heard anything from that. I don't know. Dev's main responsibilities right now are the Super Darn workshop and also CEDAR. So he's got his hands full at the moment.
And
Also,
CEDAR when is CEDAR in June? What?
like it's the week of June 20th.
So it's the weekend before Friedrichshafen then.
Yeah.
Friedrichshafen is like the 25th and 26th, I think, the fourth weekend.
Yeah. So
I believe it's May already. Holy cow.
I know.
And then Bill was going to have one at the beginning of May that I was hoping to have hardware for, but at the rate I'm going, I'm not even going to have anything built because I don't have any parts. So
Yeah, so what's gonna go on with that?
well,
I mean,
I have an option if we can find an oscillator, which John's working feverishly on now.
Yeah.
And assuming I can get the FPGA, which is a little bit iffy because if you look online, there's none. I mean, you can't buy even one.
That's crazy.
Yeah, it's crazy. But I'm really tempted to build the board without the USB 3 chip.
Okay.
We could add it later. It's due September 15th.
Yeah.
If it's a real September 15th, that's great. It might be earlier.
Right.
But if it's later, then if I wait till September 15th and it's later, then I've waited all that time and then it could be December.
Right.
So I don't really want to do that. And really, I don't think the USB 3 is essential to our testing. And
Right.
it could be something we could add later. It's just one
Right.
chip. So we can add that later. But the chip that we're changing out now is the Ethernet chip, and that's required. So
Yeah.
I can't build a board without the Ethernet chip. What's the point? You wouldn't want to do it.
Right.
You have nothing to talk to.
Right.
So at any rate, that's why we changed the chip out. We actually have purchased the 7-channel chips already.
Okay.
And it's actually a better solution if I could get the pins. I'm going to have to steal them from somewhere. So I think they're probably going to be stolen from the Leaf module, a few of them anyway. But they're the high-speed differential 3-volt one, or I mean VCCIO ones. So they're not as important as the ones that go up to the main I/O connector. That'll allow us to run the Grape and to run the VLF receiver. Those are important. And the clock module will still drive the clock, and the clock will still come off the Leaf and come back to the FPGA. It's just that I won't get the high-speed data lanes, but you don't need those for the VLF anyway. So it's just that I would like to put them on there, but you only have so many IOs, and really when it gets down to it, the Ethernet's more important. So you'd make the trade-off.
Right.
Yeah. Well, there's still going to be enough for VLF module operation, right?
Oh yeah. I haven't touched any of those pins since 2 months ago.
Oh, okay.
So the pins that you need, I actually have them on a sheet of paper right here in front of me. But it's either those have been there forever, so there's no problem.
Okay, good.
It's just that the high-speed ones, I was hoping to have some additional capability beyond just a generic Raspberry Pi module with some high-speed I/O, and we will have a differential clock coming from the clock module, which you're going to get, and we're going to have a clock out to the FPGA directly, and we're going to have an I2C ID port, and we're going to have a few other things like that. But the massive amounts of parallel LVDS lines coming in, I just don't have the lines anymore. And there's more important to feed them to the RF modules than it is to the Leaf. Since the was actually a kind of a afterthought anyway. But as long as we have enough to support the grape and the VLF, then we're good. Because I don't really feel the need for the Tangerine to support every other Raspberry Pi hat. I mean, that's really not, we don't need that. We don't need to do that.
No.
If you can, fine. If you can't, it doesn't matter. But the grape and the VLF are two important ones that we should make sure and try and support. And I've worked with John McGibbons and you, John, here to make sure that we have IO to support both of them. So both of the important ones.
Right.
And you know, Jonathan, we could just make the VLF board an RF module. It's just that, you know, it just makes sense to make it a leaf module because it's much smaller, it's much simpler, it's lower speed, and it actually, I'd like to see a receiver and a transmitter on the RF portion and a VLF module on the top. Now you got a full VLF receiver, VLF through HF receiver, and an HF transmitter.
Yeah.
Which is probably what most people are going to want. And then the VLF's a great addition for the scientific stuff too, for lightning detection and whatever else you want to do, Whistler detection
and also it'll be good for VLF amateur radio too. But yeah, as an RF module, I mean, it just seems like a waste because it's you know, much lower speed. And
so we have 3 500 megabyte channels running to a VLF receiver.
Yeah.
I wonder why we need that.
Yeah. Unless you have a lot of channels, but
yeah.
I don't really think that we're going to need any more than 4. I think 4 is ideal.
I think you got that optimized. And the interesting thing is, I keep forgetting this board is only that big. Okay, it's only 4 inches square. And when you're looking at, you know, CAD layouts that are 2x, 4x, big full screen CAD layouts, you forget that the board's only that big.
Yeah.
And the clock module is only that big. So you look at the traces and say, oh, that's a long way away. When you measure it, it's 1/10 of an inch. So it's like, it's just not, the CAD guy told me that this was the most complicated board he's worked on in the past 5 years. He used to do video boards with flex circuits that would bend.
Oh wow!
And so he says those rival the complexity of this one, but he hasn't done anything this complicated in a long time. So I told him we just want to keep him happy, you know, doing some hard stuff.
Well, the good thing is that the VLF module would be a nice little break for him.
Yeah, it'll be a lot easier than this high density digital stuff.
Yeah.
I'm just a little concerned with the performance the noise performance, because we're cramming an awful lot in, and you know we have provision for shielding, but I hope that's going to be enough.
Well, I think you're going to see a lot of that stuff at the higher end anyway.
It won't affect you. Yeah, you're right. But
I mean,
still,
even at 100 kilohertz, it's probably not going to be that much of an issue anyway. Even at 100 kilohertz.
Well, our switching frequencies for our switching power supplies are all higher than that, so they won't affect you. They'll affect our HF board if they get into anything. And I know we have we're using forget what chip I use, but we have another project that we're working on, and we're having a lot of noise present. It was the SDR that we designed. It was a piece of medical equipment. We designed it so that we could make it into a really nice SDR if we wanted to.
Yeah.
And we're seeing a lot of noise on the receiver side. And you know what's odd? You know where the noise is coming from mostly? The fans.
From the motors?
Yeah.
Yeah.
The DC to DC fans are spewing noise all over the place.
Well, the motor windings. They love to radiate a lot of that stuff. You know, and
Yeah.
there's a lot of inductance in those motor windings that since they store all that energy, you know, they're going to radiate.
We get lots of high voltage spikes that radiate nicely.
Yeah, yeah.
Well, we ended up having to move the fan connections off the board to quiet it down, and the jury's still out. We're getting the boards back this week with the new routing for the fans and extra filtering on the boards. So we'll see. The fans are not mounted on the board; they're off board, but they were powered from the board, and now they're not going to be powered from the board. They're going to be moved off to a separate DC distribution board with extra filtering on it. So
Yeah.
Cross your fingers. I mean, learn something every time you can and apply it toward the current project, you know,
Yeah, that's true.
much as you can. So.
Oh, Bill mentioned this a while ago, and this also could be something because it's also in my wheelhouse. Bill mentioned seismographs as instruments. I could also do, and this is way down the future, if seismic information, seismic data is of interest in this project, we could do a seismic digitizer board as a leaf module.
Could you use the VLF module as the digitizer? And I don't know, I have no idea what seismic sensors look like.
Well, they're measuring frequencies of, you know, with periods from, you know, 5 seconds all the way to like 20 or 30 seconds.
But are they magnetic or acoustic or movement, or what are they measuring?
Ground motion. So it'd be movement of the ground.
So you drive a stake in and then you measure the distance, the movement between the bottom and the top of the stake?
Well, there's a couple different types of seismic instruments. One of the most common ones, or the most common hobbyist one, is called a Lehman Seismometer, and what it basically is, it's a horizontal pendulum, and it's put on the ground, and it measures the horizontal ground movement.
As it disturbs the pendulum motion?
Yeah. So if you have so that would measure, that would accurately pick up the S waves of a seismic event, of an earthquake. I don't know
if it's interesting to see what it would pick up when the train goes by on the back of my house.
Well, see that kind of stuff tends to be higher frequency, and since higher frequencies attenuate through the earth, so for detecting remote earthquakes, you're mostly looking at stuff that's you know, less than a hertz, you know, periods up to 20 seconds.
Okay. Very low frequency compared to the train.
Yeah, and so I don't know if seismic information would be useful in this case, but Bill did mention a seismic instrument once, and even put it in his software.
So any evidence, Nathaniel, of TIDs causing earthquakes?
Yes, there is actually.
There is actually? I was being facetious, but there is.
Yeah, I can send you a reference.
Oh man. So is this something that we might be interested in the future?
Mm-hmm. There are also things called VLF earthquake precursors that tend to happen in the local area of earthquakes. So if you have your VLF receiver, these events, these VLF events typically occur around 80 kilohertz. In fact, I was talking to a ham a couple months ago that did some really nice documentation on some recordings that he made. There's some papers about VLF earthquake precursors.
So is it, how much advance warning is there?
Well, the thing is, it's typically about a day with these.
Wow.
But see, we need to collect more data and understand this sort of phenomena more before we could use it as an earthquake prediction tool. A lot of the seismologists didn't really work with the radio stuff, but I like to do both, and if this becomes something that people might be interested in, a seismic digitizer would be an option for a leaf module.
Well, I think that when we get the network set up and we start collecting data, there's going to be maybe a lot of things that become apparent that we didn't really consider at the beginning.
And
a lot of use cases that we haven't thought of.
That's the beauty of this thing is because we could link different fields of science. So I would like to link seismology with VLF science and HF science. So I mean, and also maybe in the future I can do a combination VLF and seismic capture board as well.
By the way, we ordered 10 of those chips from TI.
Oh, they came in, right?
Not yet.
Okay.
So they're on order, so we're in the queue to get them.
Oh, all right, good.
So just wanted to let you know.
Right.
We thought it was worth taking a risk because if you wait until they're available, you might not get any still. So
yeah, and they're cheap enough anyway. So.
And they're cheap enough. I mean, I think it was under $100. So.
Yeah.
It was just, and really part of this project anyway. So. Okay, well, I think it's about time to QRT here.
Sounds good.
Late for you guys.
I've got to keep debugging this code. So
Which
it is
code
driving me. It's I'm doing this ray trace code thing for a project I'm working on with the ARRL, and where is it? So these are.
Have you talked to Ned and Ed at all, or is this different ARRL guys?
Ned and Ed.
Ned
I think these are.
And Ed Hare.
No, these are different. I've been talking to Bob Inderbitson.
Oh, okay.
So
he's the lab guy, right?
Bob is more like Bob Inderbitson's more like I think a PR kind of guy.
Oh, okay.
And like or more general. I'm not exactly sure what.
I'm thinking of Bob Allison. Never mind. So.
That's right. Yeah.
Yeah.
But I'm doing this ray trace between Tamitha's station and my station, and this is supposed to be solar max on top and solar min on the bottom.
Oh, okay.
And I'm trying to put the terminator on top of here, and you can see right here the terminator is right at my house. You can see here the terminator is not at my house.
In your house.
And so I'm trying to figure out. Yes, so it's not right. And I've been going back and forth with Carl Lutzel Schwab about this, and he pointed out some things that I agree with. And I am plotting it. I plot it in one way on another diagram, and in one of these things, like I think that this I think this plot is actually telling me the right information.
But you want to take a latitude and a time and convert it to a longitude, right?
Yeah, I want to take a latitude, longitude, and time, and I need to be able to tell you if it's and altitude. I need to be able to tell you if it's light, light or dark.
Yeah, because altitude is the terminator too, right?
Yes,
Yeah.
altitude. So for some reason, this is not plotting the way it's supposed to. So I've got to keep working at it.
Okay.
So
looks like you're having fun.
I'll get it. It's going to take a lot of chocolate.
Oh yeah. Where's my chocolate? I got a Three Musketeers bar down in the kitchen calling my name. So.
All right. I will talk to you later.
Okay. 7-3.
Thank you, Jonathan. Thank you, Sky. Thank you, everyone. 7-3.
Thanks, guys. 7-3. Have a good night.
Bye.